Section 8.6, concentration. The amount concentration is given the symbol lowercase c. It's equal to the amount in moles of solute dissolved per liter of solution, and the unit symbol is moles per liter. A stock solution is a concentrated solution that is used to prepare dilute solutions for actual use. The concentration of stock solutions depends on the type of stock acid. For example, hydrochloric acid has a stock acid amount concentration of 12 moles per liter. The stock acid nitric acid has an amount concentration of 16 moles per liter. Sulfuric acid has an amount concentration of 18 moles per liter for the stock acid. We can calculate the amount concentration by taking the amount of solute in moles and dividing by the amount of solution in liters. In symbols, we say C is equal to N over V. C is equal to N over V, and we can write this in our equation triangle. Let's try a sample problem, calculating amount concentration. Sulfuric acid is a solution of hydrogen sulfate dissolved in water. When concentrated, it is extremely corrosive. A 25 ml sample of concentrated sulfuric acid contains 44 grams of hydrogen sulfite. Calculate the amount concentration of the solution. Amount concentration is equal to the number of moles divided by the volume. The volume is given in this question. It's 25 milliliters, which is 25 times 10 to the power of negative 3 liters, or in proper scientific notation, 2.50 times 10 to the power of negative 2 liters. Now we need to find the number of moles of H2SO4. We can find that using our equation for amount. The number of moles is equal to mass divided by molar mass. So we need the mass of H2SO4 divided by the molar mass of H2SO4. In the question, they tell us there are 44 grams, and the molar mass of H2SO4, if you use your periodic table to find the molar mass of each of the elements in the chemical formula, we end up with 98.08 grams per mole. That gives us an amount of 0.4486 moles of H2SO4. So let's go over here and calculate the concentration. Concentration equals number of moles divided by volume. Punch this into our calculator. And we get 17.9 moles per liter. Let's use the equation to calculate volume. Household chlorine bleach is a 0.067 mole per liter solution of sodium hypochlorite, NaClO. What mass of sodium hypochlorite is required to prepare a 225 milliliter sample of bleach? We know that concentration is equal to number of moles divided by volume. We can rearrange this to solve C is equal to N over V. Solve the amount of volume. If we cover up the volume, we are left with number of moles divided by concentration. The volume in this question is 225 milliliters. That is 225 times 10 to the power of negative 3 liters, or 2.25 times 10 to the power of negative 1 liters in proper scientific notation. Now the number of moles is equal to concentration times volume. The concentration is 0.067 moles per liter. And the volume we just calculated was 2.25 times 10 to the power of negative 1 liters. If we punch this in, we end up with 0.01508 moles. If we were to make the solution, we would need to know how much mass to add. How much mass of sodium hypochlorite would we add to 225 milliliters We know that mass can be found using the amount. The number of moles is equal to mass divided by molar mass. So the mass is equal to the number of moles times the molar mass. We just determined the number of moles, and we're going to multiply this by the molar mass of sodium hypochlorite, which is 74.4 grams per mole. If we punch this into our calculator, we end up with 1.12 grams of NaClO. Please try any practice problems in the textbook, read over the section, and any LMS quizzes pertaining to this section.